Hello everyone, I am Sonali Mahajan, Assistant Professor in KVN College. In our lecture series, we are discussing protection and deprotection. Okay. In previous lecture, we see some kinds of protecting group or protecting agent which protects alcohol. Okay, which protects alcohol. From that, alkyl ether is completed, tertiary butyl ether, benzyl ether, PMB or MPM ether. Next to that, Trityl ether. These all ethers are completed. Okay. So in our today's lecture, we are going to see acetal type of ethers. Acetal means what? H and R, and instead of alcohol, there is ether groups are present. Ether group are present, or ketal group are present. Ketal and acetal type of protection means in THP, MEM, MEM, in this reaction we obtain ethers like this. Okay, acetal or ketal type of ethers. Okay. So first acetal type of protection, first protection is THP. First protection is THP. THP means tetrahydropyrenyl ether. Tetrahydropyrenyl ether protection. Tetrahydropyrenyl ether protection. Okay, means THP. Okay, THP. Tetrahydropyrenyl ether. For tetrahydropyrenyl ether, we require DHP. DHP means dihydropyral. This is called as DHP, means dihydropyral. DHP. Okay. In presence of anhydrous acid salt. In presence of anhydrous acid salt, we obtain the product like this. Okay. OR. Here OR acetal type of protection is obtained. So its mechanism, ROH as it is. This DHP oxygen lone pair will goes over here, and this will take H plus from chlorine sulfuric acid or anhydrous acid salt, and it will becomes oxygen positive charge, and here this hydrogen atom. Okay, so what will happen in next? ROH, the oxygen will attach over this carbon, and this oxygen will get stabilized. This oxygen will get stabilized, and it will becomes O and OR. This is our THP protection. THP protection. We can also write it like this: OR and here THP OR. Okay. So there are some selective deprotecting agents are there for deprotection. For deprotection, there is some selective reagent. First one is concentrated HCl in water, aqueous condition. Concentrated HCl in aqueous condition. Then next one is PPTS in tertiary butanol in presence of water. PPTS in tertiary butanol in presence of water. And third one is PTSA in presence of methanol in presence of water. PTSA in methanol in water. These are selectively used for deprotection of this THP group and obtain ROH again alcohol. Okay, this is THP type of protection. Okay, THP means tetrahydropyranil. From DHP oxygen will goes over here and it will take hydrogen atom or hydrogen from toluene sulfonic acid, that is anhydrous acid salt. Anhydrous acid salt. Anhydrous acid salt and obtain THP. Okay. Second one is MEM. MEM means methoxymethyl protection. Methoxymethyl protection. Methoxymethyl protection means MEM. Methoxymethyl protection. Okay. So from methoxymethyl protection in alcohol we have to add methoxymethyl CH2O CH3 methoxymethyl chloride in presence of NaH base. Methoxymethyl chloride in presence of NaH base. This base will, and this hydride will abstract this hydrogen atom and it will become O minus. RO minus. This O minus will attach over this CH2 and Cl will get depart and formation of CH3O CH2OR. This RO CH2O CH3. Methoxymethyl ether protection. Methoxymethyl ether protection or MEM. We can write it like this: MOM. RO MEM. Okay. This is our second acetal type of protection, that is methoxymethyl protection. For deprotection of MEM. Okay. One more thing is there. In MOM protection, if primary or secondary alcohols are present, then we take here chlorine. Chlorine is methyl chloride, methoxymethyl chloride. But if tertiary alcohol is present, then we have to use CH2I and methoxy group. Methoxymethyl iodide. For protection of tertiary alcohol, we have to use iodide. Okay, in presence of diisopropyl ethylamine. This will abstract this hydrogen atom. It will becomes O minus. It will becomes O minus and further it will attach over here. Iodine get depart. Formation of OCH2 OCH3 OCH2 OCH3. This is also methoxymethyl ether. MOM. Why we use iodine here, not of Cl? Because when we use tertiary alcohol, when there is tertiary alcohol in reaction, it is having steric crowding. It is tertiary alcohol, then it is having steric crowding. So Cl reacts slowly in this reaction, but iodine is more reactive. This is tertiary alcohol, that's why it is slowly reacts, and iodine reacts more efficiently or more fastly than Cl. That's why we will use iodine here. Okay, iodine instead of chlorine. deprotection of MEM reagent. For deprotection of MEM, deprotection we use selectively trimethylsilyl bromide. Trimethylsilyl bromide is selectively used for deprotection of this MEM reagent. Okay, MEM protection. Because this trimethylsilyl bromide we can easily deprotect this group. Okay, this is first deprotecting agent. Second is PPTS, again in tertiary butanol. PPTS in tertiary butanol in presence of water. Next, PTSA in MEOH, this methanol in presence of water, or CF3COOH in water. CF3COOH in water. Methylsilyl bromide, trimethylsilyl bromide, PPTS in tertiary butanol, PTSA in methanol, and CF3COOH, this acid in water. Okay, but this trimethylsilyl bromide is selectively used for deprotection of this methoxymethyl deprotection of this MEM reagent. Okay, and it will give alcohol again. THP deprotection. Okay, ROCH2OCH3. Methoxymethyl ether is deprotected by these 4 ways, and we obtain alcohol as a product. Okay. Next one is third one. Third reagent is MEM. MEM is completed. Third one is MEM. Means MEM. Methoxy methyl ether protection. Methyl ether protection. Okay, methyl ether protection means MEM. Okay, ROH, methyl CH2 ethoxy group is there. Okay, and then methoxy and CO. Ethoxymethyl chloride is used in presence of NaH or NET3 So nitrogen lone pair will abstract this hydrogen atom and it will become RO minus, and this O minus will attach over this CH2 group, and Cl will get depart, and formation of ROCH2 OCH2 and methoxy OCH3. Okay, this is, we can write it like this: RO and MEM. That is ethoxymethyl protection. Okay, here protection is completed. So for deprotection of this MEM reagent, ROMEM, for this protection we can use MgI2. Selectively we can use MgI2 or zinc chloride in presence of H2O, in presence of THF. Okay, then zinc bromide in presence of THF. Then fourth one is MgI2TiCl4, or fifth one is BF3 Lewis acid. By these 5 ways we can deprotect this MEM reagent. MgI2, this is selectively used for deprotection of MEM reagent. This one is selectively used for deprotection of this MEM reagent, and another reagents are ZnCl2, ZnBr2, TiCl4 and BF3 Lewis acid, and we obtain alcohol again, or deprotection of this MEM reagent. Okay, understand this MEM reagent. So next one is methoxyisopropyl ethyl protection. Next one is methoxyisopropyl. Fourth one, MIP, means methoxyisopropyl ether protection. Methoxyisopropyl, MIP, methoxyisopropyl ether protection. Okay, in which we are not going to chloride or bromide or iodide. Okay, we are going to use this alkene, Me and O, Me, in presence of H plus. Okay, in presence of H plus, and we have this RO, OMe. This is ROMIP. Okay, ROMIP. Its mechanism is like this. This alkene group Me or OMe. We are not going to use Me, OMe, this methyl and Cl, because there is more crowding, and this oxygen also shows hydrolysis in presence of this H plus. So another reaction is formed. That's why we are not using this, and in presence of H plus, it will take H plus and it will becomes Me, OMe, and here carbocation is generated. Carbocation is generated on tertiary position, because it is more stable carbocation. It is more stable carbocation. So on this carbocation, oxygen of alcohol will attack and it will becomes RO and this group methyl, OMe, and this one is CH3, means methyl. Okay, ROMIP protection. Okay, understand this one. Okay, for deprotection of MIP, for deprotection of this methoxyisopropyl ether, RO, methoxyisopropyl ether, for deprotection, concentrated HCl is required, or we can also use CF3COOH acid in aqueous condition, and we get ROH, alcohol, as a alcohol deprotected. Okay, fifth one is BOM. BOM means benzyl oxymethyl. Benzyl oxymethyl ether protection. benzyl oxymethyl ether protection means BOM, BOM protection. Okay, so in BOM protection, ROH in presence of base diisopropyl ethyl amine. Diisopropyl ethyl amine means NIPR2, diisopropyl ethyl amine. This nitrogen lone pair will abstract this hydrogen atom and it will becomes O minus. It will becomes O minus, RO minus. And our reagent is what? Okay, benzyl oxymethyl chloride. Benzyl oxymethyl chloride. For protection of BOM, we can use benzyl oxymethyl chloride. This O minus, this will attach over this CH2 and Cl will get depart, and formation of RO CH2 O C2 pH. Okay, RO CH2 O C2 pH means benzyl oxymethyl ether. Benzyl oxymethyl ether. We can write it also like this: ROBOM. Benzyl oxymethyl ether protection. So for deprotection of this BOM reagent means ROBOM, this protecting group. This is selectively deprotects in presence of palladium catalyst, palladium dihydroxide in presence of H plus. Okay, in presence of H plus, in presence of ethanol, or Birch reduction. By Birch reduction means sodium in liquid ammonia, and or by PtO2 catalyst. PtO2, that is Adels catalyst. By these three ways we can deprotect this BOM reagent 1, 2, 3, and this is selectively used for deprotection in presence of PdOH2 H plus ATOH. This BOM reagent is easily deprotects and formation of alcohol again. Okay, so today we finished this 5 acetal type of protection. Okay, 5 type of acetal protection or protection and deprotection of this 5 group. Okay, so in our next lecture we are discussing about silyl ethers. Okay, trimethyl silyl, DMS. Okay, likewise all reagents we are discussing in our next lecture. For that understanding that ethers also, or that protecting agents, you have to watch my next lecture videos also. Okay, so for watching this video, thank you so much.